Hello everyone, this is another ABAQUS tutorial. In this tutorial, I want to model a reinforcement concrete beam and applying a 3-point bending test or bending load. Uh, the cross section is 200 by 400 by 300 and consists of 4 rebar, longitudinal rebar, and the straps is arranged 100 millimeter spacing in the near to the support and 150 in the middle of the beam. The concrete we use 25 megapascal strength. We go to ABAQUS and create the first concrete uh, called concrete beam. I use a millimeter, so you can create your grid based on this, which is a 500,000 millimeter square grid line using solid and taking the rectangle and giving the height as 300, so in the x should be minus 100 and the y should be minus 150. 1 point here and the second point going up 100, 150. Now the column is drawn and now we want to give 2000 millimeter length. So this is the concrete section, and the second section is straps. Straps is we use the wire and the planer and just using this concrete. So we assume the cover is 20 millimeter or 2 centimeter, so we reduce 20 millimeter from each side. Now this is from the top, which is going to be minus 18 and minus 130, minus 130. Okay, in the first point. The second point is 80 and 130. So if I go to measure, it's 160 and this is 260. So 20 millimeter one side, 20 millimeter one side. Okay, and this is the strap. So the next is rebar. So the rebar is also using wire, and this time we can use this option, just line, draw a line. The same we can consider fixed 2000 millimeter length. And now we create it, and the last part is the loading part, this area which we want to create. We can create this time we can analytical rigid. This is better to use analytical rigid. This is called supports. Let's see one analytical rigid extrude shell. Now I can select this point, this point. I want this should be 100 and 100 by 100, 200. The extrusion is 200, which is equal to the depth of the column beam. Now we go to the property and define the properties. We have concrete and steel rebar. Here is one of let me show you the concrete CDP material 25. I will put this the link of this concrete you can download, and one steel material. This is steel rebar. Now you can see this is the concrete CDP, density, elastic, concrete damage plasticity properties, which is usually uh, default from the document you can get. And this is a compressive tension, which is a maximum 25 megapascal, and the tensile behavior is about uh, using this equation at least 10% of the concrete damage concrete compressive strength. And also the tensile damage parameter is here, this data. You can get this data from the description link, and it's the steel material. You can see plastic, and I will put this data, you can use it. Now we want to create some section. The first section is uh, concrete. The concrete is solid, homogeneous, and I select. And the second one is I should create first some profile. One profile is I used beam, circle, and you can call the rebar. So that's 16, which is cos radius 8. And the second one is I can take a copy of this one and then just call it is the wraps. The straps is 6 millimeters, so it becomes 3-meter radius. Now we finished, and here again, and this time I can call the rebars, and the rebar is using beam. You can also use truss rebars, and the material is steel. The second is the wraps. You can use the same body straps and also steel material. For the this part or support, we don't need material for discrete edge elements. And now I can go to column and assign, and here is the column, and the second part is rebar, uh, rebar, and stirrups. So next I want to define orientation, because for the beam element we should define the orientation. Okay, and for rebar also need to define orientation, otherwise it will not consider, it will get error, which means so this element will not receive the properties. Now we go to the assembly. In the assembly we can bring first the concrete beam. We can use this uh, rendering or wireframe model, and then we can bring the straps first. Now there is straps, and we want to bring the rebars as well, and I want to rotate this rebar using this angle. And now the next thing is I want to select this one to bring to this point. Now next I want to populate the rebar. I can go to select this and go to turn off, parts, and I can go to beam column remove. Even I can use this commands. Here is this one is replace all. This is called remove selected. Now I can go to select this one, and the height is 260. I can select the top, and now here, and the bottom is 160. So this is should be this side. I should give here, and now here is the other report is created. So next I want to move this straps a little in the z direction, uh, 0, 0, and just 20. Sorry, it should be 0. Instead of point, I should give comma and 20. And now I can go to this direction, and we have four points, about 500. So I should create 5 this side, 5 this side, and the remaining should be 115, which is about 7, and totally become 17. Now I can go to select the populated again and select this one, and just giving this direction, and this is should be turned off, and here giving 100. So just I want 5. This is 1, 2, 3, 4, 5, and now it's okay. Okay, and now again one more, selecting this, and this time 150, and this is would be off. Now again, so 1, 2, 3, 4, 5, and this is 6, 7, and that 6 is okay. And we're going to select again, and this is the 100, and selecting this direction and going to populate to end. So this is very long. I can go to use 60. So okay, uh, in case I can create, I can move a little this side, this middle to here. So suppose the middle one is 200. So I go to back to here, and this one select. Uh, this is the middle one is this one. So I want to select these two, and taking the first point is selecting 0, and then 0 comma 0, and I want to 50 milli, which is about 530. So now it's quite right side, and you can go to 3D and see it. So we can go to view, rendering the rebar. So now you can see this is the rebar. Now we can bring all, and here is all the structure. So what I want to do is just I want to rotate, uh, select all this and bringing to the XY plane, so that's a little uh, seems better. So I'm going to select using this function, okay, and so I want to select this selecting this axis, and it will be returned like this. So one more times I can go to take this one, and taking this point to 0, 0. Again, this point to 0, 0. Now it's correct, and the next is the support area, and I'm going to bring the support, and I want to offset them to do not touch. So now I can but before this I should create some partition. So because I want to put this in the 100 here, 100 partition side here, and the middle. So I go to back to the part, we cannot partition there, and in the part here I use let's first create some data plan, and this is called offset data plan, and I'm going to select this this one is create data plan offset from plan. So now I select this one, and it won't me flip to get there, and it's by using 100. So one data plan is here. So again I select the same, and this time is should be about 900. Okay, and should be 900, which is that should be 950. I can delete that data plan here and create one more here, one more, and selecting this one, flip, and this time should be 950, and then again, and this time should be 1050. So that's equal 100 in the middle. Now the last one is okay, and 1900. So exactly this area. Okay, now we can partition here using the data plan and just selecting using this one, this option. There's one partition cell using data plan. So I'm going to select this, create partition, is create, and then select this one and create partition. Select this one and create partition, and the last one. So this is make the mesh much more better, because in case if we couldn't create this one, and later the contact between this and support will create some disconvergence and also some sort of instability between elements and nodes. So we go back to the assembly, and now the location is quite good. So what I want to do is to just leave this assembly here, uh, and I'm going to step. Okay, but I want to, let's finish step by step. So I'm going to populate this. Just we need one, two, three. So we go to this one, should be turned off, and I want to create one more. And now I can select this one and select this one, and this point to this point, and selecting this one, this point to this point, and the last one, this point, this point. You also can consider some steel support, but that steel support you apply actually some materials properties meshing, so they will take some time. During analysis they will consider as a structure, but this one will not consider. So the purpose is just applying load upon it. And now we go to the step. We have choice to conduct static and dynamic. So I should say that why we're using dynamic or explicit or standard. So mostly for this case, so the concrete is a very complex nonlinear material. So we should consider some solver that can solve a very large nonlinear properties. Uh, so for this reason, I use dynamic explicit. And also there is, in the practical, the load applying in this kind of structure is static. So we have choice. Uh, okay, now I want to do the static. Now I called static. In the static, uh, I want to consider 1 second loading time, 1 second loading time, and considering this option should be activated, so it will uh, dissipate some fraction energies between the contacts and between the especially interactions, and also activating the nonlinear geometry. Here I want to give large number, so during the analysis it will not require least number of increment. And uh, step time is I use 0.1 and minimum minus 15, so the maximum should be 0.1. And next, in the output, because we have damage parameters, we should consider the damage parameter as well. So here in the failure, I can check these two: concrete damage and tension damage, compressive damage, and also the this one, scholar stiffness degradation for quiz, and some state which is using failure plasticity model. Okay, and next, in this area I want to create uh, some point because mostly in this kind of experiment we usually push this by some sort of jack or actuator. So that means we pushing in that pushing also needs some force. So we use some displacement. So here we want to create a reference point. In that reference point, we want to apply load. So that load should be applied directly to the this element, and this element transfer to the concrete beam. This one, and the second part is in the bottom area. So I create one point here as well for the boundary condition, and one point here for the boundary condition. I click called these two, and now I want to create some time history output. So we have two choices to create time history output. Uh, to Because we want to conduct a simple supported connect condition, so we can measure this beam deformation, this joint deformation in the X, and also the vertical deformation in this point. Now we should create at least two nodes, but before this I should create here some set. Let's create set. In this set I want to measure this load, this deformation in X, because I want to apply a ruler. So when we pushing load here, so then they will some deform. Now I want to call U1 and then select this point. The next is I want REF, reaction force, in this point in the third Newton law. When we pushing something, they will create reaction. So that reaction measured by our giving displacement. So that's equal to the sum of vertical reaction force of this beam. REF plus U. So plus U means the same reaction and displacement. Now, sorry, that should be before. Then we creating set. And this one is called U2 REF U2. So REF U2 should calculate from this point. Now it's okay, done. And now here I should create those now I can rename it this output called U1. We selected here set and here U1. So in the U1 we want to just select U1 in this direction, and the second is here REF U2. So REF is the reaction force in the vertical, and So that means RF reaction force in the y direction, and U2 is also in the vertical. So that if you measure the displacement in these 2 points in the bottom of this element is same. And in a finite element method, when you're considering an element, so the element, if you have a single element, the deformation in each node is equal, except for the shell elements. Now we go to here, select set and select RF2. Here we want to get that U2 and RF2. Now it's okay. We created two time history output. This make us our work quite faster than we, instead of uh, going manually take the point and then calculate it. So now we, in the step is finished. So the last one is we want to create the interaction. The first interaction is contact or interaction between rebar and concrete. So I can go to here, uh, just select, I can select uh, going to here and beam, and I'm going to remove the beam. Remove the beam, uh, also the support, remove. Now when I remove this, and I can go to interaction and create interaction. So interaction is called embed. So that embed have two elements. One is slab and one is master. So the rebar is actually the master. So because this will not deform, but instead the concrete will deform. So now go call select region. So I can go to add all, and then I can select the concrete. So one suggestion, you can better to create some set, like the concrete set, the rebar set, then it will be much more faster, and you will not do any mistake. So the first part is finished. Now we also need to create some contact between the this support and the concrete. uh, I want to, this time I want to take the manually. I want to use as create this constraint. So I won't use tie. This is tie, and I can call tie 1. So this support will consider the discrete rigid elements and the concrete surface. So now I can go to here and just beam, replace, and these three support. And now I can use this function called undo here and redo. So again here, and I can go to again called remove. So using this function, it makes it faster. So I'm going to the here and going to back. So it's like this, going to back here, and you can see. So the first surface is the surface from the this one. Now it has showing two surface. We want to take the purple because that's outside, and again call surface. I'm going to back here one more and taking this one. Now we first contact is created, and the second contact is going to uh, tie 2 T2, and then again this is it. So I want to get this surface, again purple, and again go back here, and this is removed, and I can go to select this, select surface and this surface. Now the second one is also finished. Create another one, this time also called T3, surface, and I can go to back here, and this time I select this surface, purple, and again selecting surface and this surface. So we finished this retie and embedded. So the last thing is we should create a multi constraint point, or even we can use coupling, or we can use we're going to select all, and we also can use coupling, or we can use rigid body. That rigid body is good because we want to constraint. Let's R1. That rigid body is going to consider that point is rigid with this structure. So I'm going to select first point, reference point. I'm going to select this point, or I can go to select here. So that point, exactly this point. Now here I can go to called body element. Sorry. I can go to select uh, analytical surface. Now that point should be again in the purple. Now okay, so we create it, and the second is going to called R2, and selecting this point and analytical surface and the purple. Okay, now the last one is R3, selecting this point. I can go to back to here, and instead of that one I can use this set. Now again analytical surface, purple. Now it's okay. Now we finished. We have created 7. One is embedded, and rigid bodies, and tie contact. Now we come to the loading area. So we have two load. One is for supporting or boundary condition, and the second is displacement load. The first I want to call uh, uh, in initial. I can come to here symmetric uh, BC, and here sorry it's not taking displacement. I'm going to call uh, symmetric, and I can select this point. That's node 2. Here is called pinned. So we created pinned connection, and I can also go to name, and I can call pin connection. And the second one is created initial. This time I can call and selecting this one, and going to select this point, so the vertical is fixed. And now the last one is using static. In the static I called push, which is this point. So in the push I select here and giving this point. Now here is in the negative, and I use a minus 30 millimeter. So 3 centimeter is very huge, and it can distract the structure. And now we create it. So one more thing I should say, even I can go here, just make 0 other direction, just like this. And The roller part is also, you can, instead of picking a point, and you can select that set. Now it is finished, so we go to mesh. We go to part mesh, and here is the meshing will be much more better. I want to use less full T, and the rebar should be 80. If you made from trace, you should go to here and then select trace. Otherwise, it automatically will be B. And now straps, and the strap is also 14. And the support don't require meshing. Now we can go to here, and here is, so we go to job and create job. Now we're gonna go to submit it. And now it start running, and we want to see if there is any error. We will fix. It's a start, and it's fortunately got the first step 0.1 second. Yeah, the second is also started. So it will need some time to finish. After it's finished, so we will return back and see the result. After a few hours, it's completed, and it took about 1100 step. And now I go to result. And this is the result. So let's now it's showing just the concrete damage, and we want to see the stress strain. It's include the rebar. We want to remove the rebar. This is concrete beam replace, and you can see. Now let's see how the load impact the beam, and I want to make a little let's scale it a little larger, 50 times. And now we can see exactly, first it will begin here because this is roller support. It will move. Here is we can go to the concrete compressive damage. So the concrete compressive damage didn't reach because this is a moment which is mostly tension, and here is the tension damage, which critically the bottom of the beam, and the bottom of the beam, and also the support area. This is roller, so it will not damage. Now we can go to show the rebar and adding all and removing the concrete. So we should go to the stress strain and apply all, and I can go to back to here and go to here, remove the concrete beam, remove. Now you can see how the reinforcement create stresses and strain across the rebars. So mostly stress is concentrated in the bottom of the rebars, and even showing some buckling, and finally it buckle. Finally here it will buckle. I want to stop in that time step. Yes, exactly, you can see here. Now we want to go to the output, time history output. We already created 3 output and we can see it here. Here is which we already giving u1, u2 and reaction force. So the first I want to save all of this as it is, and we can go to now create some curve. So the first curve is the vertical displacement with vertical reaction force. Combine, I use a -1 times the u2 and a comma -1 times REF2. So then I can save it called uh, force displacement curve. Uh, one is this one and another is going to clear. I should say one in the x is the positive, so this time is a little different. So we create again operate. In the operate we combine, so we will not times the u1, this time called u1 and comma -1 times REF2. So we created this time called force displacement. So this force displacement is u1, which is the support deformation. Okay, and I can go to delete others, just plot these two. Now we can go to C. This is the response. This is the response curve of the beam. So the red one is the vertical displacement via reaction force, and the second one is the green one. The black one is displacement in the support area via reaction force. Now you can see how difference is, and so there is nothing else. You can perform such analysis and you can get this result. So this is the end of tutorial. If you have any question, please put in the comment and I will find time to answer you. And you can download this file in the description. See you next time.